Hey guys, hello everyone. Yes. Uh, my name is Arun. I'm a physics faculty, a physics lecturer, having almost 9 years of experience. I'm into this Unacademy since last 2.5 years. I have done plus courses, I have done several classes, and this is my first YouTube channel. This is first YouTube class on Unacademy. Where I can explore myself, I can learn myself with the help of you. Before I get into the class, I would like to give you a few details regarding the Unacademy's plus subscriptions. So the best plans for Karnataka CET to for 2021 aspirants is available. Right? So comprehensive batch is live for the complete syllabus preparation. Right? So for 12 months, it is 12,375, right? Approximately 1,000 rupees per month, right? For 6 months, it is only 10,125 per month, and for 1 month, it is 2,250. This is only for new subscribers, right? So, so what are the facilities available? So which is the best part of this. That is premium content at the affordable price, the structured live classes, quizzes and plus dedicated live doubt clearing sessions, quizzes at the regular interval of time, batches for the complete preparation, uh, test series for DBPs, full length mock tests, etc. with analysis, and obviously single subscription for unlimited access. Right. So these are the things which are available. Right. So you can make the best use of it with the help of by choosing your own plans. Fine. Now, so let's begin the class without wasting any time now. So in the next upcoming 2 or 3 classes, I'm going to discuss about the next 2 classes. I'm going to discuss about work, power, and energy. So why I'm discussing this is my first class. Why I'm discussing work, power, and energy first. Normally in any of your competitive examinations, it may be your JEE mains, it may be your NEET, or it may be your Karnataka CET, or any board examinations, right? You will have at least 2 questions, 1 to 2 questions from work, power, and energy, right? In this, the major questions is going to arise from few selected topics, right? I will share you the details of the graph of the topics in the next class, but in today's class, I'm going to tell you I'm going to brief you on what concept you have to empathize, on what concept you have to stress, and on what concept you are supposed to learn with more intensity. Fine. So in work, power, and energy, you have numerous questions. You have numerous concepts, especially in that, on the basis of work energy theorem, and on the basis of collisions, you're going to have most number of questions on the basis of kinetic, on the basis of your work energy theorem, and on the basis of collisions. You're going to have the most the questions. You can see in the last 10 years, 35 questions has been arised in numerous competitive examinations. It may be Kerala CET, it may be Karnataka CET, it may be Punjab CET, it may be Delhi CET. Right, it may be Maharashtra CET, NEET, or JEEs. 39 questions since last 5 years, so last 10 years in work power energy, in that too in collisions, right? And coming to your, if you are looking at the concept of the work energy theorem, you are going to have in the last 10 years, you are having almost 25 to 28 questions in last 10 years in all sort of examinations. So this would be an important chapter, especially for any of the competitive examinations. Mechanics is an important chapter, obviously, right? So I'm going to begin with the mechanics, right? In mechanics, you can see I'm going to start with the work, power, and energy, right? Work, power, and energy. So I would like to thank Unacademy for giving me this opportunity to teach you on the YouTube platform. And moreover, thank you for giving the opportunity on the Teachers' Day itself, so that I can have a very great start. Fine. Now, so before getting into the question and solving it, right? So let us just try to recall what do you mean by a work first. What do you mean by a work? Right? Yes, Nikhil, thank you so much. Happy Teachers' Day. So thank you so much. Yes. So if you ask me, sir, what do you mean by work? Right? Now, I would like to tell you what do you mean by a work. See, an object is there. An object of mass m is there. Right? So if you have an object of mass m, if you apply a force F, to this, right? An object of mass m, and if you apply a force F to this object, if you have applied an minimum amount of force to move this object, means that this object is going to move for a displacement of x or yes. Right? If you apply a force, and if the object gets displaces, then a work is said to be done in physics. Right? A work is said to be done in physics. Right? So we define F is equal to F dot S. Force is a vector, displacement is a vector, right? But work done, it is a scalar. So F and S, product of two vectors giving to a scalar, means that must be a dot product. Right? So W is equal to F into S cos theta is the scalar form of this expression. That is F into S cos theta. Because you might have seen number of expressions, number of instances where you will apply the force, the object will get displaced in any other direction. Right? So theta is an angle between the force and displacement. Right? So if you apply the force and if the object gets displaced in the direction of the applied force, then theta is equal to 0, because force and displacement, when the two vectors acts in the same direction, then if two vectors act in the same direction, the angle between the two vectors must be equal to what? 0 degrees, right? So W is equal to F into S, that is work done is said to be maximum. Right? Say, I'll take an example that you have an object of mass here. You are lifting this object to a height of h. Right? Now, work done by you is nothing but work done by the applied force is nothing but F into S cos theta. Theta is equal to 0. So F into S is the value of F into H. It is the work done by the applied force. But what about the work done by the gravitational force? What is the direction of the gravitational force? Gravitational force will be acting downwards. Right? Gravitational force is acting downwards. Right? However, in this case, the object, the force is acting downwards, but the object is displacing in the upward direction. Right? So the angle with the force and displacement vector is 180, since both are acting in the opposite direction. So work done by the gravity is given by F into S cos 180. Cos 180 is minus 1, so Wg is equal to minus F into H. Right? So minus F into H. Right? So this is the work done by the gravitational force. So this is the basic definition of a gravitation. So the basic definition of a work done. Right? So a basic definition of a work done is the body gets displaced in the direction of the applied force, then the work is said to be done. What is the equation? It is F into S cos theta. If theta is equal to 0, then force applied is said to be maximum. If theta is equal to 90, the force is said to be minimum, because cos 90 is 0, the object will not get displaced. Say an object of mass m is there. If you apply the force, if you apply the force along your positive x-axis, but the object is getting displaced along the positive y-axis, means the angle in them is 90 degrees. Right? Or say if you have a wall, if you push the wall, whether the wall is going to move? No. What is the angle between the force and displacement? Displacement is 0, as well as angle theta is 90 degrees. Right? So this is the basic definition of work done. basic definition, right? So on this basic definition itself, we are going to solve the few problems which is required for your competitive examination also, and which is asked in your previous competitive examinations also, right? So let me write, or let me discuss those problems which have been asked and which is important with respect to your examination point of view. Fine. Have a look at the question. A body moves a distance of 10 meters. A body moves a distance of 10 meters along a straight line. A body moves a distance of 10 meters along a straight line under the action of a force of 5 meters. Right? A body is displacing for a displacement of 10 meters under the action of force of 5 meters. If the work done is 25 joules, the angle with which the force makes with the direction, of motion of the body. Have a look at it. So just try to solve it. So the distance, so an object is there. Have a look at here. A body moves for a displacement of distance of 10 meters under the action of force 5 meters, right? So this object is going to displace for a distance of 10 meters under the action of a force of 5 meters, right? The work done in moving this object for when on applying the force of 5 meters in a distance, for a displacement of 10 meters is, what is the work done they have given you? 25 joules, right? So it is 25 joules, right? You're supposed to find, what you're supposed to find? With the angle with the force makes, with the direction of motion of the body, right? So are you supposed to find what? Theta, that is W is equal to F into S cos theta, correct? You're supposed to find theta. You have W, you have force, you have S, you have the displacement. Yes, exactly, it is 60 degrees, right? Good. 25 is equal to force is 5, displacement is 10. So cos theta value is what? 25 divided by 50, 25 1, 25 2. So cos theta is equal to 1 by 2, or theta is equal to 6 degrees, right? So option C must be your answer, right? Option C must be your answer, is 60 degrees, right? So let me move to the next one now. Yes. A force of, I think, sir, when you will teach class 12th, so when you want me to teach class 12th, you tell me, I teach on the same day, right? So a force F is equal to 5 I cap plus 3 J cap newtons. A force F is equal to 5 I cap plus 3 J cap newtons, right? Is applied over a particle which displaces it from its origin to the point R. R is equal to 2 I cap minus 1 J cap meters, right? The work done on the particle is, see, again, work done you are supposed to find, you have been given force and displacement. If you have force and displacement, what is the big problem in finding the value of work done? Nothing, right? So how to find it? Let us see now. So let us solve the second one now. So work done is equal to F dot S. Work done is equal to F dot S. F is equal to 5 I cap plus 3 J cap, right? So 5 I cap plus 3 J cap, right? Dot. What is the value of R? It is 2 I cap minus J cap, right? So it is 2 I cap minus J cap, right? So now just multiply now. So what is this? 5 I cap dot 2 I cap minus 5 I cap dot J cap, yes, plus 3 J cap dot 2 I cap, right, minus 3 J cap dot J cap, right? See, we know that I dot J is 0, J dot I is also equal to what? 0, I dot I is 1, so 5 into 2 is 10, minus J into J dot J is 1, so 1 into 3 is what? 3, so the work done is 7 joules. So option C must be answer. That is plus 7 or minus 7, we got it. We got it as plus 7. So option C is your right answer, right? So I can move to the next one now. A force acts on 30 gram particle, right? A force acts on a 30 gram particle in such a way that the position of the particle as a function of time, is given by x is equal to 3t square minus 4t square, right? So 3t square minus 4t square plus t cube, right? Force acts on 30 gram particle in such a way that you have been given with a force, right? So you have been not given with a force. Force acts on 30 gram particle. That is, mass is given, m is equal to 30 grams, right? In such a way that the position of the particle as a function of time is given by x is equal to 3t square minus 4t plus t cube, right? So let me write the equation first. So it is x is equal to, x is equal to 3t minus 4t square plus t cube, right? X is equal to 3t minus 4t square plus t cube, right? 3t square, 3t minus 4t square plus t cube, yes. So the mass of the particle is given, mass is equal to 30 grams, right? Mass is equal to 30 grams, right? Now, where x is in meters and t is in seconds, the work done during first 4 seconds is, what is the work done during first 4 seconds? We are supposed to find. Let us find. It is not a big issue, right? So, since you have displacement, that is, displacement has been given in terms of x and t, where x is in meters and t is in seconds, right? Now you are supposed to find what is the work done, right? Now, since a force is getting acted on the particle, with a variable with the time, right? The force, the particle will start moving, right? If the particle will start moving, what happens to the particle? What is the energy gained by the particle? It is kinetic energy, right? When the particle starts moving, the energy gained by the particle is kinetic energy, right? If the particle has been brought to rest, if the particle has been raised to a particular height, what is the energy gained by the particle? What is the energy gained by the particle? Is potential energy, right? How do you define kinetic energy? As the energy possessed due to the virtue of its motion. The energy possessed due to the virtue of its motion is called as kinetic energy. The energy possessed due to the virtue of its position, the energy is called as potential energy, right? Hagadra, ಇಲ್ಲಿ energy, how do you define energy as? Energy, you define it as, it is a energy, you define it as what? It is an ability or a capacity to do the work, right? Here, that means that work is nothing but energy, right? Hagadra, here, whatever the work you have done is nothing but change in kinetic energy. Am I correct? Hagadra, so to find the work, try to understand what I said. Since you have applied the force on the particle, the object has got displaced. Since the object has got displaced, the particle will gain the velocity. Since it is going to gain the velocity, what kind of energy do it possess? It is going to possess a kinetic energy. Hagadre, what is the work done? Work done is nothing but what? Kinetic energy. There is nothing but change in kinetic energy, and you can write, or just simply kinetic energy, half m into v square. So to find the work done in this case, you are supposed to find what is the value of velocity, right? So to find the value of velocity, I have displacement. How we can get the displacement how we can get the velocity with the help of displacement? Yes, if we differentiate x with respect to time, or if we differentiate velocity with respect to time, then we are going to get a velocity, right? So how do you define velocity? V is equal to dx by dt. Rate of change of displacement with respect to time is velocity, right? So v is equal to dx by dt. So to get the value of v, I am supposed to differentiate this. So x is equal to 3t minus 4t square plus t cube. So dx by dt of this is what? Dx by dt is equal to what? 3 minus 4t square, right? 4t square difference of 3t is 3, right? 4t square difference is what? 8t plus 3t square. So I got the equation for velocity. V is equal to what? 3 minus 8t plus 3t square, correct? So this is the equation for velocity. Hagadre, initially at time t is equal to 0, what is the velocity at the find marana? Then at the end of how much second it is? At the end of 4 seconds, right? So At the time interval of 4 seconds, what is the velocity? Let us find. Then let us find what is the change in kinetic energy. That's it, right? So V at 0 is given by, yes, 3 minus 8 into 0 plus 3 into 0. Am I correct? So V at 0 seconds is given by, see, 0 into anything is 0, 0 into anything is 0. I can write 3 meter per second. I can write the velocity at t is equal to 0. At t is equal to 0, the velocity of the given particle is 3 meter per second, right? Similarly, let us find what is the velocity of the particle at t is equal to 4. At t is equal to 4, V is equal to 3 minus 8 into 4 plus 3 into 4 square is 16, right? Now V is equal to 3 minus 8 into 4 is 32 plus 16 into 3, 48, right? Now 48 minus 32, how much is that? It is 10 plus 16 minus 3, it is 13 meter per second, right? It is 13 meter per second, right? So W is equal to change in kinetic energy, half m V final square minus V initial square, right? You can take half m common. If you take half m common, what you can write? Yes, if you take half m common, yes, V final square, that is 13 square is 139 minus 3 square is 9. Mass is how much we have? Mass is 30 grams, I feel, right? So mass is 30 grams. So 30 into 10 power minus 3, sorry, minus 3 divided by 2 into 160, right? Now 1, that is 280. So this must be 2400 into 10 power minus 3, or simply 2.4 joules. So the work done on the given particle, got the option. Sanmati, yes, it is 3. Good. I feel it is option. This is the one. Yes. What's the answer we got? It is 160, right? 13 square is 169 minus 3 square is 9 multiplied by 30, right? So 1 it is 260, so 280, right? So 80 into 30, right? It is 2.4, it's 2.4 joules must be the answer actually, right? So what's the answer we have here? It's 30 grams T cube. Then we have changed in first 4 seconds, right? T is equal to 0 to T is equal to 4 seconds. Yes, alternate correct. Okay, where we have went wrong. This is 0, okay. That is 4 3 T square, 16 into 3 is 48. Yes, okay. So thank you Shivkumar, thank you. So yes, so 2.4, right? Changing kinetic energy, sure it is. Yes. Okay, so the answer must be 2.4 joules, right? So let us not waste the time on this. So 2.4, while typing I might have written something wrong, right? So the answer must be 2.4 joules itself, if I am not wrong. Or the procedure is like this: you have the value of x, differentiate that one, you're going to get the value of velocity. After finding the velocity, find what is the change in kinetic energy, right? Right? So next, let us move to the next, not wasting too much of time. Now, a block of mass 2 kg, is placed on a smooth horizontal surface. A block of mass 2 kg is placed on a smooth horizontal surface. Two forces, F1 is equal to 20 newtons, and F2 is equal to 5 newtons, start acting on the block in opposite directions. Right? Starts acting on the block in the opposite directions. If the block gets displaced by 5 meters, in the direction of the net force, then the work done by F2 is, right? So let us find what is the value of work done. See, so in this class the first few problems would be on work, how to find the work. Next few problems would be on how to find the kinetic energy, and tomorrow's class how to find the potential energy and then collisions. This is the flow of the class, right? So today is 5th September, right? On 7th September again I'm having one more class, right? In that class we are going to discuss about potential energy, power and collisions, 3 concepts. In this class, work and kinetic energy and work energy theorem, 3 concepts, right? So totally 6 concepts we have been divided into 2 classes, fine? So now let us find the answer for this question now. You have the object of mass 2 kg where F1 is equal to 20 newtons and F2 is equal to 5 newtons, right? So mass of 22 kgs, right? Mass of 2 kgs, right? Now F1 will be 20 newtons and F2 will be 5 newtons. Obviously, in what direction does the object will get displaced? In what direction does the object will get displaced? Yes, the object will get displaced in the direction of the net force, right? Because force is a vector quantity, right? So what is the value of net force? Net force is 50 newtons. Since both are acting in the opposite direction, the net force would be 15 newtons, right? If the net force is 15 newtons, then 2 kg of mass will move along the positive x-axis. As simple as that, right? Now, yes. So if the net force is 15 newtons, the particle is going to travel in the direction of 15 newtons for a displacement of 5 meters. Right? So the particle has got displaced for a displacement of 5 meters. Now, what is the question they are asking you? Have a look at here. What's the question they are asking you? Yes. The net to work, then the work done by the F2. Then the work done by F2 is how much? You're supposed to find what is the work done, right? Supposed to find what is the work done by F2, not F1. Which one is F2 here? F2 is 5 newtons, right? Since F2 is 5 newtons, it is acting in what direction? It is acting in the opposite direction, right? But the particle is traveling towards along the positive x-axis, right? So W is equal to F into S cos 180. Why it is 180? Because F2 is acting in this direction, but the object is getting displaced in the opposite direction. F2 is cos 180. Angle between them is 180, right? So it is 5 into displacement is 5 meters because F2 acted is 5 meters. Displacement is 5 meters multiplied by cos 180 is minus 1. So work done would be equal to minus 25 joules. Work done would be equal to minus 25 joules. Yes, correct, somebody, that's correct. So it's going to travel along positive x-axis, but the work done you are going to get it as negative. Why? Because the object is getting displaced. The object is getting displaced in a direction opposite to the force applied. How force applied? Because they have asked in the question what is the work done by F2, not the net force. What is the work done by the net force? We can find that one also, right? What is the work done by the net force? We can find net force. F net is equal to what? Yes, into cos theta, right? Since the object is displaced in the direction of the work done, so it is, so the force applied, it is 15 into 5 into cos 0 degrees is 1, so it is 75 joules, right? Correct? So if they ask you for net, go for net. If they ask you for a specific force, you go for that particular force, right? Keep the things in mind. Now, let me move to the next question. A string is used to pull. A string is used to pull a block of mass m. A string is used to pull a block of mass m vertically up. A simple question, but very important, easy to understand, but a bit twisted. A small twist is there. A small twist, right? A string is used to pull a block. A string is used to pull a block of mass m vertically up. Vertically up a distance h. Vertically up a distance h at a constant acceleration g by 3. At a constant acceleration of g by 3. Right? The work done by the tension in the string is the work done by the tension of the conductor. Sir, Work done by force versus resistance or work done by tension. What is this for? Alright? Tension is a force, yeah. Yes. Tension is a force. It's a contact force. Right? Now you're supposed to find what is the work done by the tension. Try to understand. A simple problem. Very, very simple problem. Try to understand this one. Yes. You have a block of mass m. You have a block of mass m. It has been connected by a string. Right? It has been connected by a string. Right? With the help of this string, you have moved it for a distance of height h. Right? You're going to move it for a distance of height h. If you pull it upwards, tension would be acting in the upward direction. T must be acting in the upward direction. Right? If T is acting in the upward direction, whenever you get a problem like this, first you write the free body diagram. If you write the free body diagram, that free body diagram will give you 90% of the answers. It is going to give you 90% of the answers. Trust me. Right? Now, what is the free body diagram? mg would be acting downwards. Tension is acting upwards. Okay? mg would be acting downwards. Tension is acting upwards. Right? Now, since the body is moving, let us apply Newton's second law. What is that Newton's second law? F net. What is that F net? T minus mg. Why? The body is moving up, right? So it is T minus mg. T minus mg. F net is equal to T minus mg, right? Are you following it? Now, if F net is equal to T minus mg, by Newton's second law, F is equal to what? M into J, correct? Now, T minus mg. So T is equal to what? Ma plus mg, or T is equal to, if you take M common, G plus E, right? This is the value of tension in the given string. T is equal to M into G plus A. This is the value of tension in the given string. Now try to understand. If T is equal to M into G plus A, right? Then I have got. Have a look at the given question. The block is moved vertically up to a distance of height h at a constant acceleration of g by 3. Am I correct? At a constant acceleration of g by 3. What is the acceleration of the block given? It is g by 3, right? So A value is g by 3. So T is equal to M into g plus g by 3, right? Yes, Nikhil, it is mh by 2. Let us see whether it is mh by 2 or not. Fine. So T is equal to M into C, 3 plus 1, it is 4g by 2, or simply I can write the value of tension. T is equal to 4mg divided by 2, right? Now find what exactly you are supposed to find. Remember the question. What is it? What has been asked? You have been asked to find work done. How will you find work done? Work done is equal to force into displacement. Obviously, the object is moving in the direction of the force applied, that is in the direction of the tension. So the angle must be 0 degrees, right? So F is nothing but T dot S. What is the value of S? It is not S, it is H. Correct? Because it has been moved for a distance of H. Now, what is the answer now? W would be equal to T is 4mg H divided by 3. So the option is 4mg H divided by 3. That is option D must be the answer. Right? It is not mg by 2, guys. It is 4mg by 3. See, look at the application now. Look at the application level. What is that application level? You know how to find the work done. How did you find the work done? Force into displacement is the definition for work done. Am I correct? If force into displacement is the direction for the work done, force into displacement is the equation for the work done. What is force here? You are supposed to think. That's it. Yes, what is force here? Is nothing but tension, right? What is the value of tension? I found out. How did you find the value of tension? By applying the free body diagram, right? I applied the free body diagram. I got what is the value of tension with the help of the question, because in the question is given that acceleration is g by 3, right? Once I get the value of tension, I am going to substitute that in your equation. W is equal to F into S. What is F? It is T. What is S? It is H. Substitute, simplify. right? So let us move to the next one now. Yes, see the normal tendency of the students, right? What is the normal tendency of the students? Whenever you look at a diagram, whenever you look at a question with a diagram, you get confused. Instead of using it, you get confused. The best part, students, just try to understand. The best part of the diagram is the diagram itself will be having the answers. 90% of the diagram will be having the answers. You're just supposed to understand. You're just supposed to apply it and tell you. Especially in mechanics. Especially in mechanics, right? Now let us read. Let us study the question and let us answer this question. In how many steps? Let us see. Because it looks complicated, but it is not as complicated as you are thinking, right? A block of mass m is pulled along a circular arc by means of a constant force F. A block of mass m is pulled along a circular arc by means of constant force F as shown. Right? The work done by this force, Mohammed Noor, is this enough for KCET? Of course not. Of course not. I'm having so many questions to solve. Nothing to worry. Right? You have work for energy in 2 sessions. Right? I would like to cover as much as possible. Right? Okay. So a block of mass m is pulled along a circular arc by means of a constant force F. Right? As shown. The work done by this force in pulling the block from A to B. Is, right? Option A, F into R by 2. Option B, FR. Option C, root 3 F into R by 2. Option D, MGR. I am going to solve this problem in only 2 steps. Because it is a very, very simple problem. It looks very complicated, but very simple problem. If you really have the knowledge of work power and energy. Let us see. Let me write the diagram so that you will understand it better. Fine. So you are having a block of mass m is pulled along a circular arc by means of a constant horizontal force, right? Now, so you are applying a constant horizontal force, right? Now, it will reach this particular point according to this equation. Have a look at it, right? So this is R. They have given you this is R, right? So now, this is R, right? So this is 60 degrees from the equation. Now the force is getting applied. You are supposed to find what is the value of work done, right? You are supposed to find what is the value of work done by the applied force. Am I correct? F is equal to W is equal to F dot S, or F into S cos theta, not it. Right? Have a look at here. Do you know what is the value of the displacement? See, try to understand. You are supposed to find what is the work done by the applied force. Am I correct? What is the direction of the applied force? The direction of the applied force is along horizontal. It's acting along positive x-axis. Right? It's acting along positive x-axis. Right? Since it is acting along positive x-axis, you need to measure what is its displacement along positive x-axis. Right? You need to measure what is its displacement along positive x-axis. Right? So let us see. If this is your R, that is from here to here it is R, I can split that into its components, right? So this must be your R cos theta and this must be your R. That is, it has got displaced for distance of what? R. Right. What is the work done? Work done is equal to F into R. That is sine 60 degrees. What is the value of sine 60? W is equal to what? F into R, root 3 divided by 2. F into R, root 3 divided by 2. Right? That must be your answer. Right? F into R root 3 divided by 2. Right? That's option C must be your answer. Option C must be your answer. Are you following this? Yeah. Let me move to the next one. Yes. This is a question. This is a question which is having multiple answers. This is a question which is having multiple answers. So normally in NEET, this is a type of question you might have seen, because more than one answer is correct, more than one option is correct. This is such kind of case, right? You have to get exposed to these kind of questions. You have to get exposed, right? If you don't expose, right, you see in any of the competitive examination there will be a different types of questions. Say if I ask you JEE mains, normal is one thing you know, that is one option is correct. The next thing is more than one option is correct. Next thing is you will be given with a paragraph, like in your essay, in your English, you will be given with a paragraph. Will be, below that you will be given with the questions, right? You're supposed to solve that one, right? So like this, there are different types of questions, assertion and dissertations, right? So these are types of questions where you have to get exposed continuously, right? Now, so I'm telling you, get exposed to those sort of questions, right? Get exposed to those sort of questions as much as possible, right? So this is one such type of question which is having more than one option correct, right? Let us understand the question and let us verify which are the right answers and which are the wrong answers, right? Now, a block of mass 0.1 kg, a block of mass 0.1 kg is hanging. A block of mass 0.1 kg is hanging over a frictionless light fixed pulley. A block of mass 0.1 kg, a block of mass 0.1 kg is hanging over a frictionless light fixed pulley by an inextensible string of negligible mass. Let me write the diagram of it better. I don't want to take any sort of risk. Let me write the diagram. Fine. Yes. So a block of mass 0.1 kg is hanging, right? It is hanging on a frictionless horizontal pulley, right? So the strings are inextensible. Fine. The mass of the inextensible, the mass is also negligible, right? The other end of the string, this point is important, the other end of the string is pulled by a constant force F. The other end of the string is pulled by a constant force F in the vertically downward direction. The other end of the string is pulled by a constant force F in the vertically downward direction. Okay. Yes. The other end of the string is pulled by a constant force F in the vertically downward direction. The linear momentum of the block, increases by 2 kg meter per second in 1 second. A small hint is given here. A small, very small. Just very small. I'll show you what is that later. Okay. The linear momentum of the block increases by 2 kg meter per second in 1 second. After starting from rest. Then option A, the tension in the string is F. Let us verify whether the option A is correct or not. Right? Okay. Now you have a block of mass 0.1 kg. On the other end, you have been applying a force of F. Right? If a force of F is acted here, then tension T would be acting in this one. Right? If tension T acts here, then obviously T acts in the opposite direction here also. because whatever the T acts here, the same as the T is acting in the T is acting on the other side of the pulley also, right? Hagadre, I can write F is equal to T, first case, right? Hagadre, my first option is correct. The tension in the string is F. It is clear, right? My first option is correct. Fine. What is the tension in the string you are supposed to find, right? What is the tension in the string you are supposed to find? Let us find the tension also. Fine. Let us find the tension also. Now, write a free body diagram for this. What is a free body diagram? Downward it is M into G, upward it is tension. So, what you can write? It is T minus mg is equal to F. Am I correct? Now, what is this F? F is nothing but what? Yes? For that, you have given a hint here. What is that? 2 kg meter per second is the momentum in 1 second. That is, instead of F, let me tell you, I am writing with a different thing so that you can, it's the change in that you can understand, is equals to dp by dt, right? dp by dt, right? Now, what is this change in momentum? It is 2 kg meter per second. What is the time taken? It is 1 second, right? So now, let us substitute now. So T I am supposed to find, T is equal to 2 by 1 plus m into G, or T is equal to 2 plus mass is 0.1, G is 10, so it is 0.1 into 10 is 1, so tension is 3 meters. Tension is 3 meters. Whether option B is what? The tension in the string is 3 meters. Yes. Option A is correct. Option B is also correct. That's very good. Excellent. Now let us find option 3. Then option C. The work done by the tension on the block. The work done by the tension on the block. The work done by the tension on the block during this 1 second piece. This is something you're supposed to think. The work done by the tension on the block, right? Work done by the tension on the block, right? Work done. How do you find work done? How do you find it? Yes, how do you find the work done? Work done is given by force into displacement. Am I correct? How do you find the work done now? Force into displacement. How do you find the to find that work done? To find that work done, what they have been asking you? They have been asking you to find the work done by the tension. To find the work done by the tension, right? So how do you find the work done by the tension? In the place of force, you're supposed to substitute what? In the place of force, you're supposed to substitute the value of tension. That is T is equal to how much? It is 3 meters. Am I correct? If you substitute the value of tension T is equal to 3 meters, tension T is equal to 3 meters, that is the end of it, right? Now, there's one more thing. What is that? You're supposed to find what is the displacement, right? How will you find the value of displacement? That's again biggest thing. Yes? How will you find the value of displacement, right? See, because to find the work done, you have the force, right? W is equal to T into S, right? So to find the value of this displacement, yes, how do you find the value of displacement? Displacement can be found out by, you have equation S is equal to ut plus half at square, because you have been given the time in 1 second, right? So displacement you're supposed to find. So to find the value of displacement, you have the value of time T is equal to 1, but you don't have also the value of acceleration. How will you find the value of acceleration? Acceleration is given by what? Yes, find the value of acceleration in terms of this. A is equal to what? So use the same equation. T minus mg is equal to F net, right? Or m into A is equal to T minus mg, right? Or A is equal to what? T minus mg divided by m, right? T is 3 minus m into g is 1 divided by mass is 0.1. So again, acceleration would be equal to 2 divided by 0.1 means, how much is that? 2 divided by 0.1 means 20 meter per second square. 20 meter per second square. So the acceleration we have got is 20 meter per second square. So S is equal to, initial velocity is 0, half, 20, T value is 1, so 1 square. So displacement is 10 meters, right? Since the displacement is 10 meters, let's find the value of work done now, because you're supposed to find what is the work done by the tension, right? So work done by the tension, W is equal to tension is 3, displacement is 10, so it is 30 meters we have got, 30 joules. See, work done by the tension we have got as 30 joules, right? But they are given you is what? 20 joules, right? Hagadre, Option C is incorrect. Option C is incorrect. Right? Nikhil, 20. How we get 20? Yeah, you have to get that, right? So let us see whether option D is correct or not. What is the work done against the force of gravity? The work done against the force of gravity is 10 joules. The work done against the force of gravity is 10 joules. Again, how will you find work done? Work done is given by F into S, right? W is given by F into S, right? Now displacement is anyway 10 meters we have found out, right? Now what is the gravitational force getting acted? It is mg, right? So it is mg into S, right? Obviously the direction would be the opposite direction, it is 180, right? So now mass is 0.1 into 10, displacement is 10. Am I correct? Right? So now what is the value of this? 0.1 into 10 is 1. 1 into 10 is how much? It is 10 joules. So the work done by the gravitational forces 10 joules. Work done by the gravitational forces 10 joules. Whether that is correct or not? Yes. Work done by the force of work done against the force of gravity is 10 joules. Hagadre option A is correct, option B is correct, and option D is correct. Only option C is incorrect. Only option C is incorrect. ಈ ಕ್ವಶನ್ ನಿಮಗೆ ಯಾವ ರೀತಿ ಬೇಕಾದ್ರೆ ಕೇಳಬಹುದು. Which are the options which are correct? A, B, D. Right? Which of the following is incorrect? It is option C. Right? That is work done by the tension we have got 30 joules, but here it is given as 20 joules. Right? So let's go to the next one. Guys, are you following it? Okay. A time dependent force, F is equal to 60. A time dependent force, F is equal to 60, acts on a particle of mass 1 kg. A time dependent force, F is equal to 60, acts on a particle of mass 1 kg. Right? If the particle starts from rest, the work done by the force during the first 1 second is, okay, force is given in terms of 60. You're supposed to find what is the value of work done, right? How will you find this one? Yes, work done find ಮಾಡಬೇಕು. ಏನಾಗ್ತದೆ? What exactly is happening? So a force is getting acted on a particle with respect to t, on varying with respect to t. So these are the questions. The next few are the question which is based on variable force. ಇದಕ್ಕೆ ನಾವು ಮಾತಾಡಿದ್ದು it is a constant force. Now I have to shift a concept now. I am going to shift the concept from constant force to a variable force, right? So if I shift the concept from concept of constant force to variable force, then the force is variable with respect to time t as given in the question. A time dependent force. You won't believe. This is your JEE mains question in 2017. Either in 2017 or it must be in 2016. Any one of it. Rather one not there. Right? I don't remember how many it is. 2016 or 17 JEE mains question. What is there in this one? Whether it is JEE mains question or not, we have to decide. Right? Let us see. Let us try to solve it. Right? Now, yes, a time dependent force F is equal to 60, acts on a particle of mass 1 kg. If the particle starts from rest, the work done by the force during the first 1 second is, yes. So you're supposed to find what's the value of work done, right? Fine. To find the value of work done, nothing but here work done is nothing but change in kinetic. Simple. It's nothing but change in kinetic energy. So work done is going to be what? Half m into v square. Right? So change in kinetic energy is v final square minus v initial square. Half m into v final square minus v initial square. So you're supposed to find the value of v final and you're supposed to find the value of v initial. Am I correct? Now, how to find that one? You have been given the force F is equal to T. Now, previous question they have given in terms of x. Correct? X ಕೊಟ್ಟಿದ್ರು, right? They have given me x. I could differentiate that one so that I can get the velocity, right? But here they have given me F itself. but I am supposed to find what is the value of its final velocity and initial velocity. How to do that? Let us stick to the basics. As simple as that. Let us stick to the basics. What is that? How do you define F by Newton's law? M into A. Am I correct? It is M into A. That is equal to what? 3 into T. Fine. That's fine. That's great. Good. Next. How do you write A as? A is written as see, M into rate of change of velocity with respect to time. That is equal to T. Right. dV by dt is equal to dt. Yes, that's fine. Very good. Now I can write dV is equal to 3t by m multiplied by dt. I can write this one. I need velocity. I have dV. What you do? Yes, we are going to integrate that. As simple as that. Right. So integrating both sides. On integrating both sides. What is the limit? You're supposed to apply limit? No. First 1 second, right? 1 second. Okay? You're supposed to apply from 0 to 1. Right? Now, find the velocity equation first. Let us see that later. Fine. So integrating dV is equal is nothing but V. Mass is, what is the value of mass? Mass value is 1 kg. So 3t divided by 1 is 3t itself. 3t with respect to dt. What is the integration of t? Integration of t power n with respect to dt is what? T power n plus 1 divided by n plus 1. Right? Sorry, I forgot right here. So it's equal to t power n plus 1 divided by n plus 1. Right. So V is equal to what? 3 into t square divided by 2. 3 into t square by 2. Right. What is the value of t here? T is equal to 1. So V is equal to what? 3 by meter per second. 3 by 2 meter per second. T is equal to 0 means what? T is equal to 0. So V3, this is V0. This V is equal to what? 0. Again, W would be equal to what? Half. Mass is 1. So it is 3 by 2 square. It is 9 divided by 4 minus 0. Right. W is equal to what? 9 divided by 8. Or it is 1 point something. Right. Right. So this is how you are supposed to find what is the value of work done. Right. This is how you are supposed to find what is the value of work done. Right. So now let us move to the next question without wasting any of the time now. Right. So what is the answer we got there? The answer we got there as 1.1. Right. So the answer we got there as 1.1. Right. So where exactly we went wrong? Let us see once. Let me see once. Yes. Where exactly I went wrong? Okay, I have typed the question. Sorry, I have written it as 3t, right? Sorry, it is 6t. I'm extremely sorry for it. It is 6t, right? 6t. I'm sorry. It is 6t, right? So this is 6t, right? Everywhere it is 6t. Sorry. So it is 6t. Sorry, extremely sorry. Right? T square by 2. 1 it is 2t. So it is 3t square, right? So you need to get what is the value of at the end of 1 second. So it is 3 meter per second. At 0 it is 0 meter per second. So now the work done is equal to what? Half into m into v final square. That is 9 minus 0. Mass is 1. So it is W would be equal to what? 9 divided by 2. Or W is equal to what? 4.5. Right? Okay. Okay. So I feel the time is up. Right. So in tomorrow's class, I'm going to continue not tomorrow. On 7th, I'm going to continue the same, so that you can get the more knowledge, inform your friends, so that they can watch the classes. Right. So try to attend the class as much as possible. Right. In another 2 or 3 classes, we are going to finish off the work power elements. Right. So thank you for joining today's class. Thank you so much. So once again, have a great day. Bye bye.